I'm presenting this paper. It's a little different from the papers that I've seen since I've been here, all of which, in one way or another, had some evidence in them, with I think the exception of Larry's paper. You didn't have any evidence in your paper, did you?
No, I did not.
Yeah.
Evidence.
So it's an applied theory exercise. You can tell me whether or not you think it's interesting. I do think it addresses the topic of the conference, identity and inequality. And it builds on some old, and I mean old, work of mine going back to this paper from the early 90s with Stephen Coate on stereotypes. And what we're interested in exploring, myself and Young-Chul Kim, a former student who's at University in Seoul, is what happens in a world where the kind of collective reputation stereotyping that I have studied in other work takes place against a backdrop where people have the ability to, at a cost, present themselves in such a way that they are identified as belonging to one or the other of a multiple set of identifications or classifications that are at play. In the, if you will, classic Coate-Loury formulation of the collective reputation stereotyping phenomenon, what you have is ex-ante or exogenously specified categories like male, female, black, white, and so on, that people have no control over. They fall into one or the other. And what you have is incomplete information on the part of, let's say, employers who are unable to assess at the level of an individual with perfect fidelity the relevant characteristic of that individual, let's say their productivity, and who use generalizations about the category from which the individual is drawn to interpret the noisy information that they might have about that individual. So they form a conditional expectation of the productivity of the individual based on the noisy information that they can see, which is idiosyncratic, and also based on what they know about the collective from which the individual has been taken. And what we observe in our analysis is it's possible that even if the exogenously determined collectivities are, as a statistical matter, identical, that is, the distribution of unobserved productivity within these respective populations is the same, nevertheless, it might be possible for the employers in equilibrium to have different beliefs about the mean productivity of individuals drawn from the two populations, because should they begin with those beliefs, they might be led to interpret the noisy idiosyncratic information that they have about individuals in ways that create incentives for the individuals to confirm in the equilibrium the presumption that the populations were different. Is that clear? Everybody sees what I say there? Okay, so that's not a new idea. It's very much not a new idea. I don't claim that it's a new idea. I hope it's still an interesting and relevant idea, but in any case, the new idea that we have, so mildly new idea that we have, is to ask, well, what happens in such a world when the individuals in question can take some action in advance of encountering employers that colors the way in which employers classify them? Okay? So we're going to make the identity endogenous. Now, the identity that I'm talking about is the identity imputed by an observer. It's not the identity adopted or embraced by the individual, very different in spirit from that understanding of the notion of identity. So that's what we're doing. Now, you know, we've got some casual observations here about why this might not be an uninteresting exercise, okay? By reference to examples in the world in which it would appear that something like this is going on, that is, in which it would appear that people really do take actions that affect the way in which they're going to be classified by others, knowing that the observer will have conditional beliefs about the individual that are influenced by the classification. Okay? So Koreans in Japan, my colleague Young-Chul Kim, who's a Korean, tells me, have engaged in some behaviors that would allow them to disguise their ancestry in such a way that they'd be understood to be, as it were, native Japanese, even if they have Korean ancestry. Speaking the King's English, I'm going to make some reference to this paper by Jeff Grogger, in which he uses data to try to estimate the effect of on wages of African American workers of their speaking in a manner that a listener can clearly discern to be a black person speaking. People obviously can, with effort, exert control over how it is that their speech is interpreted. Other examples, there's a little note by Han Ming Fang who observes in a spirit not dissimilar to what it is that we're going to be doing here, that people might want to evidence traits. They might want to signal their productivity by evidencing traits that are not themselves explicitly productive, but that are easier to acquire by people who are productive. So this is a very classic signaling idea. I also have reference to some of the work of Kerwin Charles and Hurst and Rusanov, a nice paper that they have about conspicuous consumption as a signal of people's incomes. Sanskritization, okay, so this is the phenomenon within the South Asian caste culture of caste-identified individuals, maybe across generations, investing in modes of self-presentation that would lead them to be classified at a higher, within the hierarchy, caste. I just took this quote from one of the early books from the 1950s about this phenomenon. Caste systems, not rigid movements possible. The way the movement is affected is by the adoption of behaviors, vegetarianism, and so forth, that are associated with higher caste. The phenomenon of passing for white. I repeat the observation about the Japanese and the Koreans in Japan, but you also find this amongst African American populations. Young Chul dug up this fact that I didn't know from the NLS about, you have a longitudinal survey and people are asked to classify themselves racially, and some fraction of the sample who defined themselves to be black in 1979 had become white or other by 1998, and so on. Again, passing for white, it turns out that a certain race relations expert, this is an Atlanta newspaper that I've taken this from, but apparently the claims that are made in this story are correct, that there are a number of prominent Hollywood personalities over the years with non-European ancestry who've worked very hard to make it not public information that they had this non-European ancestry, including going to the extent of changing their interaction with their own relatives so as not to betray their non-whiteness, because it might damage their brand. Someone here will remember Carol Channing as a prominent personality about whom this is said to have been true. And then there is, of course, our dear Eliza Doolittle. This is the fictional character from Bernard Shaw's Pygmalion, the film My Fair Lady. This is Audrey Hepburn down here from that 1960s film. And I discovered that there is another Eliza Doolittle who was a contemporary pop musician from England. There you have the two of them, but who's taken the stage name of Eliza Doolittle after this character. But the story in Bernard Shaw was that the linguistic professor says he can take a woman whose Cockney accent is so thick you couldn't mistake the fact that she's lower class origins, and he could make a lady of her by teaching her the rain in Spain falls mainly in the plain and other such exercises. She would learn to enunciate those vowels in just the right accent and so on. So this is Grogger's paper, and point being that, does this thing have a pointer? Yes, it does. Point being that listeners are pretty accurate in being able to assess the race of the person to whom they're listening. This is audio files that are in the data set, and experimental collaborators or whomever were asked to listen and then check whether they think the person is black or white. They get it right 77% of the time in the case of blacks in these data. And also the observation that with various different ways of measuring how distinctly black the speaker's speech is, one nevertheless finds statistically significant negative associations with the speech being more black on wages, holding constant the conventional human capital type variables. This for African Americans in recent times. Hurst and I won't go on with this too long because our time is limited, but I always thought this paper was entertaining and interesting in this respect. They've got data on conspicuous consumption and race, and it turns out that blacks and Latinos spend more on conditional income on luxury items like jewelry and cars and clothing than do whites. And what Charles Hurst and Rusanoff are able to show in their data is that a plausible account of that is that because they come from groups that have on average a lower income, if they individually have high incomes, one way of exhibiting to observers that they have high income is through consuming items that can be seen by the observers, and this could account for this disparity. And support for that, this is the sort of stereotype about the two guys, they're both making $100K at the startup, but this guy's got on $5,000 worth of clothing, or maybe it's $20,000, and this guy is, he went to the Target and so on. What they find is that it's not only true about comparing blacks and Latinos to whites, but it's also true comparing whites who live in the South to whites who live in the Northeast, that the Southern whites, conditional on their income, are observed to spend a bigger fraction of that income on conspicuous consumption. So that's the backdrop motivation for one to do this exercise. Okay, so the rest of this talk is going to be about the exercise, which means that I'm going to present a model, and then I'm going to massage it, try to derive a result, and then I'm going to talk about the result and leave it open for questions or comments or criticisms or whatever. Okay, so we're going to allow groups to be endogenous in this model, and we're going to show that when that happens, and you get equilibria with the groups having different, this by the way is on the assumption that there is no connection between the economically relevant characteristic of an individual, which is not observable, and the categorical characteristic of the individual, although that's going to be chosen here, but there's no connection. It's going to be chosen because it's going to be costly to present oneself as one category versus the other. That cost is going to vary in the population, but it's going to vary in a manner that's statistically independent of the it's economically relevant in and of itself, and it varies in a manner that's statistically independent of the economically relevant trait. In a world where people couldn't choose their way in which they would be classified, in which they were simply given in one or the other of the categories, the corresponding assumption would be that the populations given in this category and that category are endowed with the same distribution of economically relevant traits. Okay, so then the inequality of reputation that emerges in equilibrium is interesting, since it is a kind of discrimination. Groups are equally endowed as a statistical matter, but they end up being treated differently in the equilibrium. What we're going to show is that when you allow for the possibility of people to elect how they will be perceived, and when an equilibrium comes about in which the constructed categories are in equilibrium believed to be different on average, that the disparity in the estimates of the mean productivity as between the two categories will be greater than it would have been if people had not been able to elect how they were going to be perceived. So the option of opting out or of managing one's self-presentation so as to influence the categorizing behavior of the observer is associated in our model with an exacerbation of the disparity between the groups. And the mechanism for that, which will emerge quite naturally here, and it's not rocket science, it's a relatively intuitive idea, is that there is a selective effect of the opportunity to opt out, such that the benefits from doing so are positively associated with the intrinsic unobserved productivity of the individual. The people who are going to get the most out of passing are the ones in the group who are the most productive of the group's population. So even if we started out on the assumption that there was no association between the cost of presenting in this or that category and the value to an employer of a worker, if we start out with that presumption, in the equilibrium, when people are free to elect how they're going to be perceived, the ones who opt into the group that is better thought of are going to be a disproportionate draw from the high end of the population. Okay? So that's the idea that we're going to be trying to illustrate. And the intuition for this is what I just said. Okay, so if the group identification is exogenous, people are simply male or female, black or white, there's nothing anybody can do about it. That's the way they are. And if those groups are equally endowed as a statistical matter, the way you end up with inequality and equilibrium is through a kind of positive feedback. If employers think better of one group than the other, thinking so and observing the noisy signal about an individual, they then react by, let's say, offering wages in such a way that the return to becoming skilled for somebody in the group that is better thought of is higher than the return to become. So there needs to be a positive association between the reputation of the group and the incentive for people in the group to become more productive. Okay. They're going to have an endowment. That trait, the endowed trait, is exogenous, and it's distributed in the same way for the two populations. But then they're going to make a choice. They can either invest in human capital or not. If they invest, they will be even more productive than if they don't invest. The return to investment is a function of the reputation of the group, because investment influences the distribution of the noisy signal of their productivity, and the employer's interpretation of his observation of that signal depends upon the group's reputation. So investment, the return to investment, is a function of the group's reputation. When that's an increasing function, it needn't be. It in general won't always be, but when it's an increasing function of the group's reputation, there is a complementarity between reputation and investment. When that's the case, the possibility of an equilibrium with inequality emerges. That is to say, a high estimate of the mean quality of people in the group leads employers to offer terms which create incentives for investment that are large enough that sufficient number of people in the group invest so as to justify the employer's high expectation, and likewise a low expectation leading to terms being offered that create incentives for investment that are low enough that sufficiently few people invest so as to warrant the employer's low expectation. That equilibrium phenomenon depends upon this complementarity that I was talking about. So that's how we're going to get inequality in a world in which the group identities are exogenous. When the group identities are endogenous, however, given what's going to be demonstrated here, which is this positive selection effect, you've got not only this kind of incentive feedback, but you also got a composition effect so that the better thought of group is endogenously composed of more productive people, as well as endogenously more productive because of the incentives associated with what the employers are offering. Okay, so that's the idea. So let me just start by reviewing this model in which group identity is exogenous. We've got these words phenotypic and ascriptive floating around here, and that could be confusing. Here's just what we mean. Phenotype is just given, it's in your genome, there's nothing you can do about it, that's the way you look, that's the way you are. That's the word we're using to represent group identity being fixed and not subject to any discretion. Ascriptive is meant to suggest that people can make choices about their actions in such a way that when observers see those actions, the observers will classify them in one way or another. That's the world of endogenous identities or endogenous categories. And we're going to contrast those two worlds. So the first thing I'm going to do is sketch this theory, which is really just a reprise of the work that Coate and Loury did those decades ago about phenotypic stereotyping. That's the old school story. And then build a model in which we allow for the endogenous choice of how you will be classified by an observer, and analyze in the context of that model the possibility of ascriptive stereotyping. Okay, so that's what we're going to do. and again, this is just repeating stuff that I've already said. A selective effect is going to interact with the incentive effect to create greater inequality. Okay, so here's a model. Here's the statement of the results, I'm sorry. Key result, positive selection and inequality. So there are going to be two affects, and we're going to show that the talented tend to choose, if A is better thought of by employers, to be in a disproportionate way to be in group A, and the inequality that results is greater when that's possible. So here is the model. Okay, so very simple story. Agents can elect how to present themselves. Okay? So they can be an A or they can be a B. Based on that choice, they will then be perceived as belonging to a collectivity of A's or collectivity of B's by an employer. There's a cost to an individual. It can be positive or negative, just a normalization here of the individual being perceived as an A. If you like, if this number K is a positive number, that means the individual is naturally a B and they have to do something costly to be perceived as an A. And if it's a negative number, then you can think of that as the individual being naturally an A, and then they have to do something that's costly to themselves to be perceived to be a B. Okay. This parameter K is exogenous and is a part of the endowment of an individual, and it's distributed in the population in a certain way. So there's a cumulative distribution function for this parameter K defined on the real line. And we're going to assume that there's no built-in tendency for a majority of the population to be one thing or another. This is a relatively innocuous assumption, you'll see, but it simplifies the analysis. We're calling it affective symmetry, and that just means that what it says here, the fraction of people whose cost is below K is the same as the fraction of people whose cost is above minus K. That means that the density function is going to be symmetric about 0 in this population of people of the cost of being an A or B. So there's no there's no bias in the natural orientations of the population to one or the other of these categories. Nothing else were going on, and if they had no reason to make choices other than what they were naturally inclined to, half the population would be A's and half the population would be B's. This is Young Chul. I don't think we even need this assumption here. But individuals are going to make a forward-looking estimate of what the returns are from being perceived by employers to be one or the other, and they're going to elect the group that is best for themselves, taking into account the cost of presenting themselves one way or the other. Okay, so individuals are going to make a choice about whether to be perceived as an A or B, and they're also going to be a choice about whether or not to enhance their productivity from an employer's point of view or not. Okay. So this variable E, which is a discrete investment decision, represents the individual's choice about whether or not to acquire human capital. Ability is a negative correlate of this parameter C, which is the cost to the individual of electing to acquire human capital. Low-cost people are more able than high-cost people. There's also a distribution of this cost in the population, which we're going to assume to have a density that's single-peaked, which is going to make the cumulative distribution function have an S shape. Okay, its slope will start low, rise to a peak, and then fall off to being low again. That's for convenience so that we can simplify the set of equilibria where there are multiple equilibria here. You'll see how that goes in a minute. Again, it's not essential to what it is that I'm going to say. And there's a density function there, and so individuals choose to become skilled if the return from doing so exceeds the cost. Of course, the return from doing so is going to depend upon how they're classified in equilibrium. The assumption that identity has no bearing on productivity is captured in the model by the assumption here that these two variables, these two cost variables, are independent of one another. Knowing one doesn't tell me anything about the distribution of the other. Okay. So that's the story. The paper that I've referred to before and that I've described here briefly proceeds in the following way. What we want to do now is model how the employer is going to make use of the collective reputation of a population. Okay. The idea is that a person either becomes skilled or they don't. If they choose E equal 1, then they throw off a noisy signal which the employer can observe. He cannot observe their E, but he can observe the signal. And the distribution of that signal is more favorable than if they choose E equals 0. So when the employer sees the signal, he can draw an inference about whether or not they based E equal 1. The higher the signal, the more likely it is that they chose E equal 1. But that inference is going to depend upon the character of the population from which he presumes the individual to have been drawn. Right? So the estimate of the productivity of the individual, which is the likelihood that they put E equal to 1, will be a function of both a signal, which is specific to the individual, and the employer's belief about the group from which the individual comes. Okay. So modeling that involves, as I say, just taking it that the employers get to observe some noisy signal of the individual's productivity. The distribution of that signal is conditional on whether or not the individual invested in human capital or did not. And this monotone likelihood ratio property is just a way of capturing that uniformly higher values of the signal are associated by the employer with relatively higher likelihood that the individual put E equal to 1 is investing. So the employer, this is just using Bayes' rule, uses his prior belief about the population, the fraction who had put E equal to 1, together with the properties of this investment contingent distribution of the noisy signal to formulate a posterior estimate of the likelihood that the individual invested. This is just Bayes' rule, prior probability of investment times the conditional likelihood of a particular score given investment over the overall rate of likelihood that that score would have been presented. We're assuming here that an individual produces an amount W if they are an investor, and they produce the amount 0 if they're not an investor. So their value to an employer is W times the likelihood that they are an investor, and that value is going to depend upon the characteristic of the group from which the individual was drawn in the employer's mind, and the specific characteristic of the individual who presents himself to the employer. This is then going to be the reward gross return to someone who happens to realize a particular signal value T when they come from a population about whom employers believe the investment rate to have been pi. Okay, so that's going to generate the gross returns for individuals as a result of the employer's behavior. And then fixing now for a moment the category into which an individual is classified by employers, and assuming about that category that the fraction pi are thought to have invested by the employer, we can ask the question, what's the expected gross return to an individual who does and doesn't invest? So that's simply taking what will be this should be DT, taking what will be the wage offered should the signal T be realized, and then taking the expectation of that wage under the distribution of signals associated with either investing or not investing. The E here can be either 0 or 1. So that's the gross return to if E is equal to 1, an investor, the gross return if E is equal to 0 to a non-investor, and the difference in those returns is the incentive to invest. Okay. So now, since we have such a simple framework here, we know exactly what the wage function is in terms of the signal distribution functions. And we have this expression for the return to invest in terms of the signal distribution functions and the wage. We can express the returns to invest entirely in terms of these density functions, which represent the distribution of the noisy signal conditional on investment and conditional on non-investment in this way. So we can take the derivatives and we find that this function is strictly concave in the formulation that I have here, and that it vanishes at 0 and at 1, which is simply saying if the employers were certain that no one had invested, they would offer a wage of 0 to everybody, and so the return to investment would be 0. Whereas if the employers were certain that everyone had invested, they would offer a wage of W to everyone. If they were a priori certain that everyone had invested, their posterior estimate of the conditional of the likelihood of investing is going to be 1, no matter what the value of the signal is. So they would offer a wage of W to everybody, and there would be no return to investing, which tells us that the return function pardon the independent variable being on the vertical here, is going to have to be, it's a concave function and it goes through 0 at 0 and 1, so it's going to have to look like that. Okay, so that's the employer's behavior and that's the worker's incentive to invest, given the way that employers are going to behave, conditional on what employers believe about the category from which a given worker would have been drawn. Okay, so what is stereotyping in this world? So an equilibrium in this world is a self-confirming belief. It's a belief that the employer has about a population such that when employers harbor that belief and behave accordingly, they generate an anticipated return to investment to workers such that the fraction of the population in question who invest confirms the employer's belief. That's what this equation is saying here. Remember, this is the return to investment. Remember, this was the distribution of the cost of investment in the population. You invest if return exceeds cost. The fraction of the population who will invest then, or the fraction whose cost is no greater than the return. That's G of R of pi. And so a little fixed point here is going to constitute an equilibrium. So we can then talk about the set of equilibria. Okay? And when that set contains more than one element, we can then talk about phenotypic stereotyping in equilibrium. Because when the set of fixed points to this little mapping here has more than one element, it's possible for the employers to have distinct beliefs about the exogenously given categories, which are affirmed in equilibrium. They think pi 1 about group 1, pi A about group A, pi B about group B, and as long as pi A and pi B are roots of this equation, they will be able to think that and have their behavior induce incentives in the worker population that lead the workers to behave in such a way that those thoughts are confirmed. Okay. Yes?
Could you have it be that in this case where you can't signal, there's only one equilibrium, but then when you can signal, two equilibria can emerge?
No. There could be many equilibria even in this world where you can't signal, if there are many roots of the equation here.
Yeah, but suppose there's only one root.
Yeah, if there's only one root, then there's only going to be one equilibrium in the world in which the groups can't, in which individuals can't change their, how they're perceived. That's right.
But could it be the case that there's only one equilibrium there,
Yes.
but two equilibria in the
Yes.
where you can't signal? Okay.
Yes. Okay, maybe this is a point that's worth actually emphasizing. If there's only one belief employers can have that lead them to treat workers in such a way that the incentives generate behavior in the worker population that confirms that belief, if this equation has only one root, then when there are multiple exogenously given populations, all of those, given the assumption that they were statistically identical in terms of the distribution of the investment cost, all of those populations will be observed to invest at exactly the same rate, and there can be no inequality in the equilibria that we're constructing here between those populations. However, on that very set of suppositions, that is, that there's only one solution to this equilibrium defining condition, it could still be possible when we elaborate a model where individuals are at some cost able to choose to present themselves this way or that there could be multiple equilibria in that world. So one of the equilibria in that world would be that both groups are thought of to be the same, and the same as they would have been in a world in which group identity was not malleable, in which case people would simply present themselves as either A's or B's, depending upon whether their K was negative or positive respectively, and there would be no information to the employer in that presentation, and that would be an equilibrium. But there could be another equilibrium in which one group, say the A's, were thought to be better, and because of, as I'm going to get to in a moment, the endogenous positive selection into the better thought of group, that could end up getting confirmed in equilibrium, even if there's only one equilibrium in that world when group identity is exogenous. Sorry, that sounded convoluted even to me, so I don't know how that came
I
across
understood
on
it,
people.
so that's where the bar is.
Okay.
The low bar.
If you say so.
Well, what's interesting about that, suppose I'm going way outside here, but if we had a third group, say we had We have African Americans, whites, and Hispanics. And suppose Hispanics can pass as white, but African Americans can't. Then we have, you could have the one equilibrium, and there's no way out for African Americans, but then the whites and Hispanics have coordinated so that the whites who are passing end up where we have really talented on all the white side. Now, Hispanics who get left behind are going to do poorly. Am I making sense?
Yeah, you're making sense. I mean, yeah, that's not uninteresting.
Are you assuming also noise for group identification, or just for the noise, or just for the skill?
No, the noise is just about skill. They are perfectly accurate in the A and the
employer
B.
just takes whatever the choice that the employee makes regarding affect choice, right?
That's right.
Okay.
Individuals make a decision about how they're going to be perceived, and they have probability 1 of being perceived in the way that they decide. Yes.
But in reality, there may be some kind of noise or imperfect association between employers and employees' identification of the category and employers' perception of the category.
Sure, there could be. It's not at all obvious to me at first blush how that could make a fundamental difference. That is to say, instead of individuals using...
Of course, it makes a difference because then, of course, if the other person is more difficult, it's more difficult to be perceived as the preferred category, then their cost of investment in terms of probabilistic, is higher because successful passing as a particular category is smaller.
Now, I see that. And so in the limit, supposing that, it was like a coin flip how you would be perceived no matter how you chose to be perceived, you would in effect have no control over how you were perceived. I was just trying to say, sure, one could...
I'm talking about individual heterogeneity.
Sure, one could generalize the story here to allow that there's a probability. So I take a choice to be perceived as an A, and then there's some probability P, bigger than a half, that I will actually be perceived as an A. Then I got P times something and 1 minus P times something. And if P is close to a half, I basically got nothing.
Yeah,
and if P is close to 1, I've got the world in
the
there.
probability to be heterogeneous depending on individual.
Well, that's already captured in K. You've already got K, which is the cost, and that's
Yeah.
heterogeneous. So you've kind of already got the effect that you're looking for.
Okay,
Yeah.
that makes sense.
Let's proceed and we'll see. So anyway, that's a story about what I'm calling phenotypic equilibrium, and it's, as I say, a familiar story, illustrated here. So the lazy S shape of the G function is reflected here, and you can see the possibility for multiple equilibria or for only one equilibrium. And given this lazy S and the concavity here, intuitively we're going to have a world in which there are either 1 or 3 of these intersections. Generically, I mean, there could be a tangency, and so there could be 2, but that would be a knife edge case. Okay, so it's in this world that I'm saying whites could be thought well of. Being thought well of, employers behave in such a way that there's a high return. There being a high return leads to a larger fraction of the white population choosing to invest. Blacks are thought poorly of. Being thought poorly of, there's a low return. Notice that multiplicity requires that we be in a range in which the return function is an increasing function of the reputation of the group. That was the point that I was making earlier about complementarity. Okay, and here's just a little bit of schematic, and I don't want to belabor the point. Employers start with a belief. On that belief, they decide to treat idiosyncratic information in a particular way. That treatment induces a return to the skill-enhancing activity, and then a fraction of the population, given that return, will want to enhance skill. And when the fraction who want to enhance coincides with the belief, we have an equilibrium. Okay, so a couple of observations. There's going to be an underinvestment from a social point of view in skill in this world, okay, because individuals don't internalize the beneficial effects on others of their own investment decisions. Okay. So from an efficiency point of view, too little investment will happen in the equilibria that we just got through describing. When there are multiple equilibria, they're Pareto ranked. If there's a high pi equilibrium and a low pi equilibrium, everybody is better off in the high pi equilibrium. Everybody being workers, because employers are breaking even in equilibrium. And the workers are better off in the high pi equilibrium because whether they acquire skill or they don't acquire skill, their average wage is an increasing function of the reputation of their group because employers' estimate of productivity is an increasing function of its prior. And as I've said, and I don't want to belabor the point, multiplicity of these equilibria is only going to be possible when there is this complementarity in the relevant range between a group's reputation and the incentives people have in the group to invest in human capital. Okay, so that was that. Now I want to go on and talk about what happens when we allow for people to make a choice that influences how they're going to be categorized by observers. Okay, so now the general model, individuals are characterized by these two parameters, their cost of acquiring human capital and also their cost, positive or negative, of presenting in a way that they're perceived to be an A. So what will happen is that given that employers think a group to be investing at a rate pi and reward workers accordingly, there will be a return to a worker from being in that group. And that return is either what they get in expectation if they invest in human capital or what they get in expectation if they don't invest in human capital. And they can elect whether or not to invest in human capital after having elected to be in the group. And so this is what their payoff would be from being in the group. They have the option of investing or not. Okay? So what you're going to be interested in, if you start with employers having been posited to think pi A about the A's and pi B about the B's, to have these reputations in mind for the two populations, we're going to be interested in the payoff to someone given his cost of acquiring human capital, should he be perceived to belong to group A, relative to the same payoff, should he be perceived to belong to group B. So this function here, which is the difference in the payoffs, constitutes the incentive to be perceived as an A. Should the cost of being perceived as an A not exceed the incentive to being perceived as an A, the individual will elect to be perceived as an A, and then, being so perceived, will elect whether or not to invest in human capital, depending upon his cost of investing in human capital. Right? So there's a separability in the decision problem here, the very simple decision problem. Choose to be an A or a B, given that employers harbor this pair of reputations about the two populations, and given that your own cost of investing in human capital is C, choose to be an A should your cost of being an A be less than the return to being an A, conditional on your cost of investing in human capital. Okay? Otherwise, choose to be a B. Okay. So, just some obvious things about this function. The relative value of being an A compared to a B is minus the relative value of being a B compared to an A. That's trivial. If A's and B's are thought equally well or poorly of, there's no return to being an A relative to being a B. And then finally, if A's are thought better of than B's, if the return to becoming skilled, given the reputation of A's, is higher than the return to becoming skilled, given the reputation of B's, then the return to becoming an A relative to being a B will be lower the higher is your cost of acquiring human capital. Okay, so this is the key condition that's going to generate the positive selectivity that I was talking about. The lower is C, the greater is the value of being an A relative to being a B in the event that the return to investment in skill is higher on being an A than on being a B. Okay. Imagine pi A is bigger than pi B. A's are better thought of than B's. Imagine that we have the complementarity condition, which is that if your group is better thought of, then investment is a more attractive option to you. Then, the easier it is for you to make the investment, the better it is for you to be in the group that's better thought of. So for example, suppose C were very low. You're going to invest in either case. Yeah, but the A's are better thought of than the B's. Okay, so you're going to have a return that's high from becoming an A. Suppose C is very large, then you're not going to be investing in it. The A's are also better thought of than the B's. But the point is that the differential value of being an A when your cost is low is higher than the differential value of being an A when your cost is high, even though both of those differential values are positive numbers. And this is just some algebra here that's making that point, and I won't belabor it. But you can, I mean, it's just a calculation. All I'm doing is just doing the algebra to try to demonstrate that this is the case. But I want to emphasize what this condition means. This function being non-increasing means that the incentive to becoming an A diminishes as C goes up, which means that the set of people who are going to elect to be A's is going to be disproportionate draw from the low C end of the C distribution, which is going to enhance the composition of the A group. That's the effect that I'm after here. Here's the case in point where I'm saying the return to being an A, that should be pi A and pi B, is higher than the return to being a B, and pi A is bigger than pi B. And this is what, you know, for very low cost, they both invest, and so the differential value to being an A is a constant. For very high cost, they both don't invest, so likewise, the differential value of being an A is a constant. Both of them are positive. And in this intermediate range here, where costs are in this intermediate range, you invest if you're an A, you don't invest if you're a B, and so likewise, your differential value of being an A is a decreasing function of your cost. Okay. So now, this is now getting to the point where we can describe ascriptive stereotyping equilibria. That is, equilibria where people are electing both whether to become, enhance their skill and whether to allow themselves to be perceived as belonging to category A or category B. So we want to basically do a calculation here. Who will become an A? So given a cost of getting human capital, if your cost of being perceived as an A falls short of the benefit to you from being perceived as an A, you become an A. Here's the fraction of the population with a K that is less than the benefit to being perceived as an A. That benefit of being perceived as an A rather than a B depends upon your own cost of acquiring human capital. So we average this fraction over the range of the human capital investment cost. So the expression that I have written here is a weighted average, weighted by the frequency with which C is realized in the population of the fraction of people with that C who would want to be perceived to belong to group A. Of those, some are going to invest and some are not. The ones whose cost falls below the return from investment will invest. So the ratio of these two integrals, here is the entire rate of choosing to be in group A. Here is the rate of choosing to be in group A and investing in human capital. So with this in the numerator and this in the denominator, I have a fraction which tells me the fraction of A's who are investing in human capital. And in equilibrium, that should be the reputation of A's in the minds of employers. Right? Likewise, for B's, you invest, you elect to allow yourself to be perceived as a B if your K is bigger than the return to being perceived as an A. So that's 1 minus H. But I'm going to use the affective asymmetry assumption and the fact that delta U of pi A pi B is minus delta U of pi B pi A to observe, and this is where the affective symmetry assumption is doing its work, that I can derive an expression that looks very similar. This is the rate at which individuals in the population will elect to be B's. This is the rate at which they will elect to be B's and will invest in human capital. And so with this in the numerator and this in the denominator, I've got the conditional probability that a person who is a B has invested in human capital. Okay, so just look at these two expressions. They are exactly the same except the position of A and B are interchanged in the formulas. I'm talking about this expression and this expression relative to this expression and this expression. Okay, so that's going to allow me to claim the following. Define this function, which is generically the expressions that I had for A's and B's before, although I use X and Y's now because I wanted to apply to both groups. Define this function. Given that your group has the reputation X and the other group that you don't belong to has the reputation Y, in the group that has the reputation X, how many people would, in the population as a whole, how many people would choose to be in the group with the reputation X? That's the denominator. And of those, how many would elect to invest in human capital? That's the numerator. Okay? So this is just a well-defined function of X and Y. And an equilibrium is going to be a pair of reputations for the two populations that satisfy these two equations that I'm pointing at here right now. For A's, the fraction who would elect to be A and invest in human capital, the fraction, of those who elect to be A who invest in human capital, satisfies this equation. And likewise for B's, the fraction who elect to be B's and invest in human capital, who invest in human capital, satisfies this equation. Is that clear what I'm doing? Okay. So that's what I'm looking for. That's going to constitute a pair of numbers that have that property will constitute equilibrium with descriptive stereotyping. And the set of such pairs of numbers, we simply give the name omega KL for Kim and Loury, authors of this paper. Okay, now some observations. So first of all, there's always going to be a descriptive stereotyping equilibrium of a trivial sort here, where if I had a particular belief about a population that was a self-confirming equilibrium where there was no ability to move out, then having that belief shared between the two groups will constitute an equilibrium in this sense, because then people have no reason to be one or the other, and they'll simply incline toward the group that they are naturally, the K's negative will be A's, the K's positive will be B's, and so that'll be an equilibrium. So that is not saying very much. Should I have an equilibrium where group identity is endogenous and where one group is better thought of than the other, it must be the case that the return to investment for the group that's better thought of exceeds the return to investment for the group that's less well thought of. Because should I have an equilibrium like this, it can only come about because there's positive selection into the better thought of group, but there will only be positive selection to the better thought of group if I'm in a range of the return function that exhibits this complementarity property. Okay, so that's true. And so here's the result. So is there any questions so far? Okay, so we're going to state the result in the following way. Suppose that there are multiple equilibria of the phenotypic stereotyping sort. Okay, suppose there are multiple self-confirming beliefs in a world in which group identity is exogenous. So it's possible for there to be inequality between the groups that is confirmed in equilibrium based on this stereotyping dynamic. Okay? And suppose that across the range of such equilibria, of such self-confirming beliefs, the complementarity condition holds throughout. Okay? Then, should there be an equilibrium with endogenous group choice, it has to be the case that the better thought of group is at least as well thought of as the highest possible self-confirming belief in a world in which there were exogenous identities, and that the less well thought of group is no better thought of than the least possible self-confirming reputation in a world in which the identities were exogenous. And it's in that sense that we are asserting that introducing the possibility of self-identification, of self-presentation as one thing or another, exacerbates the disparity in reputations between the two populations relative to a world in which such self-management of the classification is not possible. Okay, so that's our result.
In this case, would you want your group to have to be easy for the other group to become, have it be very difficult for you to become part of the other group?
Yeah.
Suppose it's impossible for me to pass as African American, but it's possible for you to pass as white. Then we get the coordinate, then it has to be the white group is the privileged group in that setting, because we can't go the other way.
Who are you?
Yes, I see.
In this model, you're nothing until you make an election about what you want to be. I'm trying to translate what you're saying into
So
into what your value of K is and what my value of K is.
Yeah.
So I want to say that we got two groups, and then I guess my K is everybody. So we have one group where K is negative infinity for everybody, and then all the positive Ks are distributed in some way.
So
one group will never go to the other.
okay, so again, I'm just trying to discipline your language here. I don't have any groups until people make choices.
Sorry, it's a distribution of Ks.
Okay, so that's what you're talking about. You're talking about the distribution of Ks.
The distribution of Ks are selected.
Okay, and it's violating my symmetry condition now.
Yeah.
Okay.
But it's violating in ways so that the negative Ks you can't get an equilibrium where they'll go over to try to appear on the positive side.
Well,
I'm not saying that right.
so I think what you're trying to construct is one of your historical examples, where we can imagine that there are two groups of people for which the distribution of K is not the same, because for maybe where if you're white, you grew up, and most whites grow up in a place where they're speaking Oxford. I'm mixing up your examples. Speaking Oxford English,
No
but
problem.
some other blacks are growing up in an environment where they're not speaking that, so they actually have to. It's harder for them to acquire that accent, something like that. So then we can we want such a distribution. Now Peter can pick up, I think.
Now, I'm willing to think outside the framework of this little toy model. I'm quite willing to do that. I wanted a very simple and clean slate. I wanted a world in which basically there was nothing a priori that determined the people to be one thing or the other. And then I want to let them choose what to be. Right. You want to introduce an element in which a priori, I mean, from history or whatever, there are already differences amongst individuals in the population, but notwithstanding those differences, there are options for people to move, and then you want asymmetry in those options and to explore the implications of that. I'm quite willing to talk about that.
Asymmetry is only on the ability to choose the category, not on the...
Not on the economically relevant, the C in my language.
Right, and so then you'd have this, I guess what are you saying, Peter, that if one group simply can't pass into the other, but it can go the other direction, then you're going to exacerbate this effect that the group...
Well, then it's guaranteed. You want to be in the group that simply can't pass as the other, because then you'll get the positive selection without ever getting the... you can't be in the bad equilibrium in that case.
Okay, I'm not going to get positive selection until I have differences in the reputations of the groups. So I have to be talking about what's happening in equilibrium. And now I'm sustaining an equilibrium based upon something about the asymmetry and the ability of people to move back and forth. A's are better thought of than B's. And moreover, it's harder for people who are naturally inclined to be B's to get themselves to being seen as an A than it is for people who are naturally inclined to be A's to get themselves. Yes, sir.
Your theory is really concerned about rationality of sort of Robert King Martin said, anticipatory socialization, sort of passing as a member of the group which he or she desired to be. And my question is, of course, individual rationality is exactly what you described, that people who have low C cost will more likely to identify themselves as a member of A. But suppose that employers' prior probability differences of assigning, identifying people who are skilled versus with uncertainty is very small. Therefore, eventually the equilibrium is single rather than two equilibrium, one for A and another for B. Then obviously that eventually at the single equilibrium, the people at the proportion of making the investment is become identical between A and B, and the proportion of being treated for assigned a given desirable position and so forth become also identical, right? And then of course the making another investment for changing the membership is ultimately not rational. Is that correct?
Yes.
If eventually okay. So individual rationality and collective outcomes, rationality from the perspective of collective outcome does not necessarily agree. Depending on initial condition of the employers.
I'm not understanding the collective rationality and individual rationality.
Because the depend whether each group has a separate equilibrium or single equilibrium depends in part on the difference in the prior probability of considering being skilled on the part of the employer between A and B, right? And if it is the difference is small, then it tends to be more likely to have a single equilibrium. But if it is separate enough, they're more likely to generate distinct equilibrium for between A and B, in my understanding, in the original theory of yours, according to you.
Let me not comment on that because I'm not sure I understand the question, and there are a couple of more points that I want to make before I conclude. So if you would allow us to discuss this later, I'd be happy to pursue with you. I've got 15 minutes. So I want to do a couple of things. I want to gesture at a proof of what it is that I've claimed here, which is that ascriptive stereotyping, when it produces unequal evaluations of the two endogenously selected populations, will exhibit greater inequality than could ever come about if the populations were given a priori and choice of how you were to be perceived was not an option. So that's the claim, and I want to suggest why that's true. And then I want to talk about an example that departs only slightly from the general framework that I have here, that illustrates that even when there's a single equilibrium in the world with exogenous identity, there can be multiple equilibria in a world where the identities are endogenous, and there can be an efficiency enhancing consequence of entry. It might exacerbate inequality, but it could enhance efficiency to allow for this selection. Okay, and I want to just gesture at that. There's not going to be time to go through it fully. But the idea about this last point about efficiency is that take an extreme case where there's a breakdown, a kind of adverse selection breakdown of the market altogether. Employers think they're no good, or whatever the belief the employer has, the incentives that he generates for people to invest would never induce that many people to invest, and so the only equilibrium is that nobody invests. Okay, the market for ex-cons, let's say. Ex-cons can elect to go back to crime, or they can go straight. The employer doesn't want to hire them if he thinks they're going to go back to crime with too high a probability. So he's unwilling to offer a positive wage if he thinks that with too high a probability. But if no matter what he believes about the group, the wage that he offers doesn't generate a sufficient incentive for that many people in the group to justify the belief, the only equilibrium will be you'll hire none of them. Now introduce the possibility that some of them, by paying a cost, could see themselves to be, yeah, I'm an ex-con, but I'm an ex-con with a star on my forehead. I'm an ex-con with a certificate that says I completed 10 weeks of digging holes in the ground every morning and then filling them up every afternoon. Nothing productive about the activity that I was doing, but it's costly for me to do it and be costly for anybody to do it. Positive selection into this marked category could generate a circumstance in which there could be actually some surplus realized in equilibrium, whereas without the option of self-identifying, no surplus would be realized in any equilibrium. That's the kind of thing that I want to illustrate. So two things, if time permits. First, just gesturing at why what I've said here might be true. Intuition we've already discussed. So here's the proof that I'm going to offer. So it turns on this construct. Y is the reputation of the group that we're not looking at. X is the reputation of the group that we're looking at. And this equation says, if I hold fixed how the B's are thought of, what reputations could the A's have that would constitute at least a partial equilibrium? Partial in the sense that Y has been fixed here. It's not at its equilibrium level, but should the employers believe X prime about the A's, if they believe Y about the B's, the fraction of people who would elect to be A who would be skilled would be X prime. Okay, I'm relying on you remembering what this phi represented. It was the ratio of two integrals, one, the denominator representing how many people would choose to be in the group altogether, and the other, the numerator, representing how many people would choose to be in the group and would elect to have high skill. Okay, so I just want to consider this correspondence. For every fixed reputation of the Bs, there are a set of self-confirming reputations for the As, allowing for endogenous identity choice. Okay? Now, a Coate-Loury type equilibrium will have the property that it is a fixed point of this correspondence in this sense. That is, if I put in, remember, the correspondence fixes y and then looks for A's that satisfy this equation. Right? So if it's a fixed point of the correspondence in this sense, it's going to be a Coate-Loury equilibrium. A pair of reputations will constitute a Kim-Lowry equilibrium if the pair have the property that fixing the reputation for B's, the A's are self-confirming. Fixing the reputation for A's, the B's are self-confirming. Okay? So what I'm trying to show is if I have an equilibrium like this where pi A is strictly bigger than pi B, then pi A has to lie outside the range of these equilibria to the right, and pi B has to lie outside the range of these equilibria to the left. That's what I'm trying to show. That's what I've asserted. Okay. So now, here's a fact that's extremely useful. If the two groups had the same reputation, as I said, the election of how to be in one group or the other would just take its natural course. The K's negative would be A's, the K's positives would be B's. There'd be no difference between the groups. And so the phi function that I describe here would simply be the same thing as what fraction of a homogeneous population would invest if they saw a certain return. Okay? So one can show, based on what it is that I've said so far, that when if X is bigger than Y and the return to investment for reputation X is bigger than the return to investment for reputation Y, then the phi function has to lie above the G of the fixing Y, the phi, and letting X be the variable. The phi of X has to lie above, whereas if this inequality went the other way, it would have to lie below. Here's what that means. That means that if I think about the exogenous group world, the solid line that I'm tracing here is G of R of pi. It's a world in which there's only one population and in which employers' beliefs about that population generate returns that then induce a certain fraction of the people to invest. That was the old Coate-Loury model. Multiple intersections allow for phenotypic stereotyping. Okay. What I've said is that fix Y, and now look at phi, which is the fraction of the people with reputation X who, if the group's reputation were X, would elect to be in the group and would become skilled. Y is the other group. X is the group into which people are being imagined to elect, and phi is the fraction of those so electing who will acquire skill. And what I'm saying is qualitatively, as long as I'm in a range of the complementarity between reputation and investment incentives, the dashed line has to lie below the solid line to the left of Y and above the solid line to the right of Y. Okay? I'm just saying graphically what this expression here is saying algebraically. Okay. Now, my correspondence gamma associated with every Y a set of fixed points. I'm pointing at them right now. There are 3 of them. Okay. What I want to do is consider how that correspondence has to behave as I vary Y. When I vary Y, this dashed line is going to shift to the right. That means the low fixed point will be lower, the intermediate fixed point will move higher, and the upper fixed point will move lower. So everybody see that if I move this point Y to the right, the dashed line will shift, and based on the qualitative property that it has to lie below the solid line to the left of Y and above the solid line to the right of Y, I infer qualitative properties of the correspondence that I defined previously, this correspondence. I'm looking for the behavior of the set of these fixed points where Y is treated as a parameter, and I've observed that that behavior has to be as Y increases, the lowest element of the set falls, the highest element of the set falls, and the intermediate element of the set increases. Okay? that means that the correspondence in question has to look like what I've got drawn here. Y on the horizontal, and for any given value of y, the various x's that satisfied the fixed point condition. Okay? As you can see, if I make y very low, the upper equilibrium might disappear and there might only be one equilibrium. And if I make y very high, did I say that right? If I make y very low, the lower equilibrium might disappear and there'll only be the upper one. And likewise, if I make y very high, the upper equilibrium might disappear and there'll only be the lower one. And that's captured here. Now, the Cote-Loury equilibria are, as I said, the fixed points of the correspondence. They lie on the 45-degree line. These points are points which are equilibria in the sense of Cote and Loury. The Chem-Loury equilibria will be pairs, there will be pairs of Cote-Loury equilibrium in which the groups are treated the same, in which case choosing A or B doesn't matter. But there will be an asymmetric equilibrium if I can find points pi A and pi B such that pi B lies in gamma for y being equal to pi A, and pi A lies in gamma for y being equal to pi B. That's illustrated here in the graph. Now, the point I want to make is there's no way that I could start with a pi A for A, go up to gamma, find a pi B for B, go up to gamma, and come back to pi A, unless pi A lied to the right of this point. And likewise for pi B lying to the left of this point. This is a geometric argument, but it's perfectly rigorous. There's nothing wrong with this argument. To get an unequal, an asymmetric Cote-Loury equilibrium, I have to have pi A and pi B that are lying on the rectangle that I'm tracing now. To lie on that rectangle, they have to be outside of the part of the correspondence in which the Cote-Loury equilibria are located. You don't look convinced, Larry.
No, I'm,
Okay, you're going to sleep. It's okay.
no.
Okay, it's okay. All right, so let me stop and with, as I say, the last thing that I wanted to do was just gesture at this example, this little example. Here's the story about how a market might fail altogether with this stereotyping going on. This is the return function, the fraction of people whose cost is below the return as a function of the reputation. It goes through 0. If it otherwise lies below the 45-degree line, we're done. There's only one equilibrium, it's 0. There's the complete failure in the market because of informational asymmetry, and there's going to be no surplus generated. No one will invest. The employers will offer everyone a wage of 0. Okay. And what I want to imagine, and I say that, if you want to have a story, this could be the market for ex-cons, whereas I say the employees are worried about their productivity and can't observe it directly, and there's a noisy signal. But what I want to imagine is a program that has the property that if you were to pay some cost as an individual, and now I'm going to make this cost a policy parameter, okay? Government's going to create a program. If you like, think of it as I say. There is a non-counterfeitable, there's a non-falsifiable certificate that certifies your participation in a program, which is to say, certifies that you were willing to pay a cost to get the certificate. Okay. Employers can then see your certificate or not, and they can have different beliefs about the set of people whom they see having the certificate versus the set that they don't. They will continue to believe of the set that they don't see with a certificate that they're all no good and offer them wages of 0, as in the equilibrium that's exhibited here. But about the ones with the certificate, they might have a positive estimate of the investment rate. And it could be that it's sufficiently positive that the terms that they offer justify some of the people, the ones whose costs are lowest, the ones who are going to be wanting to invest, of acquiring the certificate. There's not a time to actually go through the algebra on this, which, as you can see, involves a parametric example where you can do calculations and figure out exactly what's going on. But what I want to say is that this is true. For every possible cost of program participation between no cost at all and a cost that's equal to the value to the employer for sure of someone who's invested, there's going to be an equilibrium with positive program participation and positive skill acquisition rates amongst the people who elect to choose to be in the program, which means positive surplus generated in an economy where there was no surplus in the absence of the program. The program participants who elect to acquire skills are going to be earning a strictly positive return. So there's going to be a weak Pareto improvement over the world in which there was no program. And I just want to make this observation, which is that an empiricist who was trying to evaluate such a money-burning program, this is a money-burning program. This is basically, I burnt money. The people who are not any good couldn't have afforded to burn money. Do you believe that I'm that good? Well, just consider, I wouldn't have been able to calculate getting a positive benefit unless I were willing to burn the money. And then the employer takes that into account, and the office turns based on that, and indeed it turns out to be worthwhile to burn the money for some of the people. But someone coming along evaluating the program, to the extent that they were careful and took into account the selection dynamic that's going on here, would have to judge the program to be of no value because it's been assumed to have a zero treatment effect. It didn't impact anybody's productivity. It was simply a device for allowing people who otherwise wouldn't have been able to segregate themselves to segregate themselves. I'm not a program evaluation person. That's going to be obvious by now. But it did seem to me that this is an observation worth making within the context of program evaluation. Finding a zero treatment effect on controlling for selection doesn't imply the conclusion that the program is socially valueless. That's the point here. Okay.
Sorry,
Thank
can you say this again? The last
Yeah.
thing, just the last thing you said?
Yeah.
I missed it.
Yeah. I said, here's what I'm saying. I'm saying in this world, the only equilibrium, if there's no ability for people to show themselves to be of a different kind, is with nobody investing and nobody being offered a wage, okay? What I'm saying is that if I introduce a program where if you want to pay the cost K, you can pay the cost, and I put a stamp on your forehead that it can't be forged, then for every possible cost that lies between zero and the highest cost anybody would pay, because this is the most employers are ever going to offer, there's an equilibrium with positive program participation in which the people who do participate and who elect to invest in human capital earn a strictly positive return. So that's a weak Pareto improvement. So it's worth doing. On the other hand, from an empirical point of view, if someone came along and said, okay, did getting the certificate make people any more productive? They would have to conclude, if they controlled for selection, that it did not, because that was a hypothesis of the whole exercise. The conclusion is that the program might fail the test of a positive treatment effect. It might fail the cost-benefit test of a positive treatment effect, and yet still be socially beneficial.
And this example, though, it's rigged so that these people selecting out have no negative externalities on the other guys who are stuck at zero anyhow.
If you want to call that rigged, yes.
No,
Correct. No,
this is
correct.
very
It
special.
has
It
the
says that in
feature.
general you have
That's
two
right.
effects,
The only way I can
which can-
conclude a weak
right.
Pareto improvement is that the guys who
You're
are not
keeping these
chosen
guys fixed.
are no worse off than they would have been if there had been no program whatsoever. And that might not be true if they moved
That
out
might
of the
not be
neighborhood and, you know,
I mean,
whatever.
the welfare analysis is very complicated, right? Because it's very rich too. I mean, you start from a symmetric equilibrium
Right.
without any choice, right? So that's the first best optimum. And then you have the statistical discrimination, which, you know, has an inefficiency because there's a group which
Right.
is lower. At the same time, though, you have pooling in the two groups, which is often kind of good welfare-wise. Now you're offering a way to people to burn money to select, which could go either. I'm thinking in terms of, I don't know, Rothschild Stiglitz. Okay, so you're offering a mechanism to separate. This could be efficient or not, depending on the sizes of the group who are separated. You see what I'm trying to say?
Yeah.
Which I think it's this last point. So you're trying to overcome an inefficiency, which is the statistical discrimination equilibrium, which is inefficient, or you're trying to overcome. I mean, you're
Right.
playing on a inefficient equilibrium by adding a dimension of separation, which can go either way.
That's I
So
think that's
that-
accurate.
right?
What you're
So
saying.
then
Yeah.
the whole welfare, it's really complicated. I mean, in general, it's really complicated.
It's complicated in general, and the example is cooked. I mean, after all, the only equilibrium without intervention was zero. What the theorem said is that you have to get more inequality, but more inequality from zero can only be something that's positive and something that's zero, which has to go in the direction of improving welfare in the example. In general, that wouldn't be the case.
So I'm just going to
We're
look
out of time?
Yeah,
Yeah.
and let's thank Glenn very much.
You're very